Let us solve for this given Bernoulli equation, but first let's try to come up with its standard form so that we were able to identify the correct notations to be used. Let us try to distribute this on both sides of our, or on both terms of our binomial expression. You will have dy over dx is equal to xy to the power 4 minus y. And then, by moving y on the other side of the equation or adding y, you will have dy over dx is equal to, plus y is equal to xy to the power of 4. Clearly, this is a Bernoulli equation because we have here n, which is 4. Together with that, the coefficient here together with y is our p of x being 1, and this is our f of x being x. So we are now sure this is a Bernoulli equation. The next thing here is to come up with a representative or equivalent linear equation representing another variable in order for us to use that in solving this equation. Of course, we have here dy over dx plus y is equal to xy to the power of 4. To remove this, let's try to multiply both sides by y to the power of negative 4. So this would be cancelled here, leaving only x on this side. So we'll have here y, power of negative 4, dy over dx, plus you have y in a negative 4, so you have y, power of negative 3, equal to x. Now that we are sure with this, it's time for us to represent this one here by an expression or a variable with exponent 1. So that this would be closer to what is our linear equation. Let z be equal to y to the power of negative 3. So that would mean this would become z with the power of 1. Together with that, if we are going to take its derivative, it's negative 3 y to the power of negative 4 dy. We need this because of our first term, we also have this representation. Since we are changing y in terms of z, we also be removing dy here in the first term as well. But since we have here 3, so we can divide both sides by negative 3. So y to the power of negative 4 dy is negative 1/3 of dz. Having these two representations, let us have the new form of our equation. Instead of y to the power of negative 4 dy, we'll have negative 1/3 dz over dx because we are not removing dx. Plus, the next will become simply z equal to x here. And since this is not yet on its standard form because you would like this to be 1, let's multiply both sides by negative 3. Hence, this is our final form. dz over dx minus 3z is equal to minus 3x. So with this, now this is already a linear equation. And with that, we can guarantee that there is p sub 1 of x to differentiate with this, being this form, negative 3, and our f sub 1 of x is this here, minus 3x. Okay, so let's proceed now to the integrating factor. We're going to integrate this or solve this z and use the representation for z earlier to get the value of y. So the integrating factor mu of x is equal to e raised to the integral of p sub 1 of x dx. E raised to the integral of negative 3 dx. In short, you have e to the power of negative 3x. That's our integrating factor here. And using f sub 1 of x in this form, we'll have the integrating factor times z is equal to the integral of mu of x, f sub 1 of x. This one here, not the other one, not the first, because we are now on z, not on y. So the integrating factor e to the power of negative 3x times z is equal to the integral of e to the power of negative 3x times your f sub 1 of x, which is negative 3x dx here. Okay? Now, as you can see, or let me continue here. E to the power of negative 3x z is equal to e to the power of negative 3x. Oh yeah, it's still like that. It's just the same. So let me save some spaces here. Okay. What we have to do here next is actually an idea that we cannot take the integral of this automatically. It's because if we're going to let, this is another part here, we're going to let u be equal to minus 3x because it's starting with an algebraic expression. Its du is negative 3dx, negative 3dx. But we have this expression here. Even if you're going to interchange them, you will have, if u is negative e to the power of negative 3x, its first order derivative is negative 3 e to the power of negative 3x dx. But we have an x here. If it's a constant, we can always move it out. But if we have x here, we cannot also use that. This clarifies the idea that we can only integrate this using integration by parts. Okay, integration by parts. So we are going to do this process. This is expressed actually in terms of u dv. We are going to solve for u and v and du. We have this form, uv minus v du. So let u be our algebraic expression minus 3x. Our du is minus 3dx. Okay, and the remaining, if this is our u, that would mean our dv is equal to, for a while, our dv is e to the power of minus 3x dx. Integrating that to solve for v, both sides of the equation, you will get v here. Of course, you need negative 1/3 because you will be adding a certain constant, negative 3, here to integrate that. So our v is equal to, okay, I don't have much space. Hopefully I could fit in everything, as after this we're going to solve for y. So you have negative 1/3 e to the power of negative 3x. So with this now, let's try to integrate this first. Hopefully, again, I have some spaces. So this follows this concept. U is minus 3x times v, which is this at the bottom, uv, negative 1/3 e to the power of negative 3x, minus v du, v, negative 1/3 e to the power of negative 3x du times negative 3 dx. Okay? This is our du here. Now we can take this out because we already have 3 here. Sorry for that. Okay, let me decrease the size. So this will be cancelled. So you have x e to the power of negative 3x. You will have, again, plus 1/3 now as you take out negative 1/3. And this remaining will be integrable now. So you have e to the power of negative 3x, negative 3 dx. So you have x e to the power of negative 3x. Okay, I don't have much space. Pardon me if I might be using another sheet for this, okay? So plus 1/3 e to the power of negative 3x plus c. Yan. This is equal to this expression, e to the power of negative 3x times z. And since we're solving for z, let's multiply both sides by e to the power of 3x. E to the power of 3x times this is e to the power of 0, so we have z here remaining. This multiplied to that, e to the power of 0, so we are left with x, because e to the power of 0 is just 1. This multiplied to that is also 1, so you have plus 1/3 times 1. And you have here plus c e to the power of 3x. Okay? So we're almost done, as we are now done solving our z. But going back to our given representation earlier, z is equal to y to the power of negative 3. Okay? So we can have simply this form. Y power of negative 3 is equal to x plus 1/3 plus c e to the power of 3x. If you would like to, you could always represent this in terms of y, but since I don't have much space, I'm just going to end up here. Of course, this is 1 over y cubed, right? X plus 1/3 plus c e to the power of 3x, and then you can reciprocate them. You can reciprocate. Y cubed is equal to 1 all over this x plus 1/3 plus c e to the power of 3x. And you can take the cube root of that if you really would like to solve for y. But let me just end here because I don't have much space. So again, this is possible. We have now integrated the integration by parts in our process in solving the Bernoulli equation. And this is for this video. Thank you very much for watching.